Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is templated classes. Before proceeding, make sure that you have already watched these other videos first. A class can be written as a generic template. As we saw in the previous video about templated functions, this templated class uses template parameters, which act as placeholders for some type. If this T0 becomes specialized to int, for example, then a specialized version of the CR type class will get compiled, where the type of mx_0 will be int. That specialization will be in common, shared across all of the class's data members and member functions. So that specialization will use an implementation of the getMember function, which returns int. If T0 also gets specialized to float, for example, then another version of CR type will get compiled, having a float mx_0 member and a version of getMember that returns float instead. Understand that this templated class definition is not compiled at the location where the class is being defined. And it's also not compiled where its member functions are defined either. Instead, the class and all of its member functions are all collectively compiled at the same time when the template is being specialized. Regarding the organization of your files, you have the same options for templated classes that you had for templated functions we discussed in the previous video. One option, if you can predict all the specializations that your clients will need, is to implement your member functions in one of your source files, and then specialize your templated class yourself at the end of that source file. Another option implements your member functions in the same header file as the class definition, usually inline inside of the class's definition. This is the approach taken by STL. Or, all but one of your client modules could use C++11's optimization that borrows a template specialization from the one client module that does actually specialize it. A member function can be a templated function, having its own template parameters that are separate from the rest of the class. This should not be attempted with a virtual function. The class could be an ordinary class that isn't a template, or the class could also be a template using different template parameters from the compute_min templated member function. This copy constructor and this one parameter converting constructor don't conflict with each other. Your class can program both at the same time. If T and T2 specialize to different types, then it's obvious which implementation will get used for any situation. But T and T2 are also allowed to specialize to the same type without any error happening. In that case, the copy constructor takes priority.